So when I was invited to give this talk, the first thing I did was I looked at some of the TED Talks online, and I found that while they covered a large range of subjects, the most common theme seemed to be how to use technology to save the world. And so my first inclination was to decline, because I thought I don't have any ideas for how to use technology to save the world. In fact, I don't think technology is going to save the world, if in fact the world needs to be saved. But then I thought about it, and I thought I didn't have just one idea of how to use technology to save the world. And that's to use less of it. So I thought, well, I can give a talk about that. That's credible. And then the more I thought about it, I thought, it is just one idea, but actually I honestly believe that it is the only idea for what to do with technology that would actually save the world. So I thought, well, maybe this is a talk worth giving. So the argument I'm going to make today is very simple. It's almost ridiculously simple. And it rests on just a few assumptions, none of which is at all controversial. In fact, they're almost, we can call them common sense. Yet they lead to a conclusion that is seen as so radical and suspect that it's generally vanished from serious discussion of how to address the big problems that humanity currently faces. So here's my whole argument. I know it's a rather dense slide, but it's the whole argument. This is it. So number one, the kind of knowledge needed to create a new technology and the kind of knowledge required to understand that technology's impact on natural systems are of an entirely different order. The invention of new tools and technologies is a heuristic process of trial and error. But once technology is widely used, it begins to impact natural systems, which are extremely complex, and our understanding of these natural systems is limited. Our understanding of natural systems has nothing to do with heuristic processes of trial and error. As technology becomes more powerful, the window between the invention of a technology and its impact on natural systems shrinks. And as the pace of technological change quickens, unanticipated systemic consequences pile up and overlap in ways that we will never fully understand. Now, none of those assertions, the idea that the invention of new tools and new technologies is a heuristic process of trial and error, this is not a contentious statement. The idea that natural systems are complex and very poorly understood, this is not a contentious statement. In fact, right here at UC Davis, we've got the Center for Complexity Sciences, which is one of the real shining lights on our campus, and they emphatically agree with that statement. So the problem is when you add these very simple, generally accepted statements together, you end up with number three. It's the pace of technological change quickens, unanticipated systemic consequences pile up and overlap in ways that we will never understand. So the conclusion I draw from that is that there are now no problems posed by technology that can be solved by more technology. Technology can only create new problems on an ever greater scale. And the only solutions are social. Okay, let's look at the first assertion. The invention of new tools and technologies is a heuristic process of trial and error, which can be adequately captured by the notion of tinkering. Okay, you start out trying to drive a nail into a board, you pick up something nearby and hit the nail with it. It doesn't work very well. You pick up something else and hit the nail with that. You start modifying the thing to make your tool more efficient, and pretty soon you have a hammer. Or, as is often the case, in the process of trying to invent the hammer, you inadvertently invent a screwdriver. You don't really have to understand exactly how stuff works, but it gets the job done. For example, this oil refinery here on the right. Gasoline, for example, entered the world as the unfortunate byproduct of refining lamp oil. It was a waste product that had no use whatsoever, unintentionally created by a different process. And then, of course, as we saw in earlier presentation today now, we have internal combustion engines blanketing the planet and creating all kinds of problems. So the invention of gasoline was actually not that different from, at a scale of much larger complexity, it's the same process of inadvertently inventing a screwdriver in the process of trying to invent a hammer. Or we could take bisphenol A, a chemical substance that's been in the news quite a lot. It was first synthesized in 1891, that's over 100 years ago. Its first use was as an early synthetic estrogen. This would be used to treat female reproductive disorders. But then when other synthetic chemicals were found to be more estrogenic, bisphenol A fell into disuse until it made a comeback a couple of decades later as an additive to plastic. It became one of the main chemicals of industrial manufacture. So again, that's an example of inadvertently inventing a screwdriver in the process of trying to invent a hammer. Today, at least 8 billion pounds of this stuff are put into industrial products every year. It's used as a plastic additive and flame retardant in bathing water bottles, sports equipment, medical and dental devices, dental fillings and sealants, eyeglasses, CDs, DVDs, water pipe lining, color developer, and carbonless copy paper and thermal paper coatings on the inside of almost all food and beverage cans. So this stuff is everywhere. Assertion number 2, once a technology is widely used, it begins to impact natural systems, which are extremely complex, and our understanding of them is limited. The human endocrine system, which each one of us has inside of our bodies, is one such natural system. When it was first discovered, it was thought to be quite simple, and now it's understood to be vastly complex. And the early work in endocrinology coincided actually with the synthesis of bisphenol A in 1891. At the time, we had only the vaguest notion of the human endocrine system. So there is absolutely no way that anybody in 1891 could have anticipated the consequences of the wide-scale use of bisphenol A on the human endocrine system. Oops, that's cut off. But if you've been reading the news lately, you know that there's a huge debate about bisphenol A now. It's been implicated in fetal and infant brain development disorders, obesity disorders, memory, learning, and mood disorders, thyroid disorders, cancer disorders, adult male sexual function disorders, heart disease disorders, diabetes, and much more. Now, all of this is highly contentious and is being debated vigorously in all kinds of forums around the world. Different political jurisdictions are dealing with it differently. Bisphenol A is in the process of being banned in most of Europe. It's not being banned in the United States. And what's remarkable here is that despite the intensive research that has now been done on bisphenol A, there's no consensus whatsoever on whether this is even a problem at all, or whether it's an extraordinarily serious problem we have to deal with right away. And this is for a chemical that was synthesized more than a century ago and has been in industrial scale production for decades. So that's the second point. As a new technology, as the use of a new technology becomes ubiquitous, it impacts natural systems, and our ability to understand its impact on natural systems is limited. Last 2 points. As technology becomes more powerful, the window between the invention of the technology and its impact on natural systems shrinks. And as the pace of technological change quickens, unanticipated systemic consequences pile up and overlap. So it turns out that bisphenol A is not unique. In fact, there are a large number of synthetic chemicals that are now known as endocrine disrupting chemicals. Once they get into our bodies, our hormone receptors confuse them for the chemical substances secreted by our hormone-producing glands. And as a result, our endocrine systems within our bodies get confused. Many synthetic chemicals are now known to be estrogenic. There's a huge range of possible effects that this may cause, because the human endocrine system is so complicated and poorly understood. Some of these effects are behavioral, and we have very little idea of how to accurately measure behavioral effects. Some effects are intergenerational. In other words, a pregnant woman who's exposed to an endocrine disrupting chemical during pregnancy, that child has to be born and grow up and have offspring of its own before the effect is discerned. There's about 82,000 chemicals in industrial production today. Less than 25% of them have ever been tested for toxicity. However, even that's an overstatement because, or an understatement, because testing chemicals for endocrine disruptive properties does not really fit on our scale of toxicity. So even 25% is an overstatement. There's complex interactions between these chemicals. We know there are, and most of us in the world have between 50 and 150 of these things circulating in our blood now at any time. So not only are there 82,000 chemicals, but there's some huge exponential number of possible interactions between them. They're everywhere now. Every person in the world has synthetic chemicals in their blood. They try to find a control group. They've taken out a map and said, who in the world lives farthest from industrial production? Maybe we can use them as a control group and they won't have any persistent synthetic chemicals in their blood. Turns out they have more than you and I do, because they tend to eat marine mammals, and this stuff is persistent, which means it never goes away, which means eventually we flush it down the toilet or down our drain and it ends up in the ocean. It works up the marine chain to marine mammals, and like Eskimos eat them. So there's no control group. It would be impossible to fund research on this scale. That's totally beyond imagination. So the result is that we won't know. We won't know. This is a really grand experiment that we are running. Let's look again at natural systems. One nice thing about the endocrine system is that there's billions of people on planet Earth, and also animals. Mammals, other animals, their endocrine systems are pretty close to ours, so we can run experiments with many endocrine systems. We can do double-blind, placebo-controlled, randomized clinical trials. And as you know, if you've been watching the news lately, there's been a multitude of sort of drug scandals where drugs that were put through this extremely rigorous testing procedure turned out to have consequences for the natural systems within the human body that were completely unanticipated. But of course, now our technology is to the point where we're having an impact on things like the global climate system, which we only have one of. We don't have billions of, so we can't do anything like a double-blind, placebo-controlled, randomized clinical trial involving our climate system. So there's no experiments, no controls. We rely on models that are knowledge is very limited, and there are many other natural systems that our technology is affecting. So one problem we're looking at in the world today is colony collapse disorder involving bees. Bees are crucial to the way life on our planet works. Currently, causes that are being investigated are disease, malnutrition, pesticides, cell phone use, genetically modified crops, or some combination of all of the above. Nobody knows. We don't know yet. But notice how recent the fourth and fifth things are. Cell phones have only been in the world very short, very few years, as have genetically modified crops. And already this technology is so ubiquitous that we are unsure of how it's affecting natural systems. So we are now to the point where not only can we cannot even accurately measure or understand the consequences of even one defined event, much less the cumulative impact of 82,000 chemicals on the global climate. I'm sure you've all been reading about the Fukushima disaster in Japan. And if you've been reading about it, you've certainly been reading about it in the media, all the questions about, is Fukushima as bad as Chernobyl? It's not, it won't be as bad as Chernobyl, or it's as bad as Chernobyl, or Chernobyl was a 7 on the scale of nuclear disaster, and is Fukushima a 6 or a 7? Well, how bad was Chernobyl? It happened exactly a quarter of a century ago. That's 25 years ago. There's been 25 years of follow-up research funded and executed by the shining lights of the Williams scientific community. So, how bad was Chernobyl? We're having this worldwide discussion of whether Fukushima was as bad as Chernobyl. How bad was Chernobyl? Well, 25 years later, our best guess is that somewhere between 4,000 and 1 million people have died as a result of Chernobyl. So how bad was Chernobyl? We don't know. Now, I'm not suggesting that I myself put equal credence in the figures of 4,000 and 1 million and a million. I have my own opinions, but what I am saying is that credentialed scientists who are people who have substance to their thought and can defend their positions are arguing both positions. And I'm suggesting that this debate will never be resolved. This is an example of technology outrunning science. If science is about anything, science is about measuring things. If you can't measure something, you're not really working in the realm of science. As we just saw, we can measure light from the beginning of the universe, or remarkably close to the beginning of the universe, that we can measure fairly accurately how much oil is left in the world, but we can't measure the consequence of interacting chemicals on the natural systems of our endocrine systems. My conclusion then is that there are no problems posed by technology that can be solved through technology. The only solutions are social, and the only real solution is to use less of it, which is what we used to call conservation, which is something that has actually vanished from the national discussion. We have all this talk about cap and trade of oil versus carbon tax versus so on and so forth. The idea that people could actually make a decision, a collective decision to make do with less, seems to have fallen off the radar entirely. Thank you.